Hello, let's do a quick guide of the equation booklet that will be in the exam with you. The equation booklet contains a lot of useful information. The next section we have is a little electromagnetism section, and we start with a definition, and that definition is for magnetic flux. And this is one where you can literally say the equation. So magnetic flux is the product, because we're timesing, of the magnetic flux density, B, and because they've got this cos theta there, really I should say the perpendicular area, just to be safe. The next equation is Faraday's law. Well, it's actually, this equation's two laws in one, but we'll start with Faraday's. And we would say Faraday's law as the magnitude of the induced EMF, electromotive force, is equal to the rate of change of magnetic flux linkage, N phi being the magnetic flux linkage there. Also contained within this equation is this little minus sign, and that little minus sign is Lenz's law. And what that little minus sign means is that the direction of any induced EMF will always oppose the flux change that causes it. And then the only other equation set that we have for this electromagnetism section is a series of equations that are to do with transformers. Transformer section here. It might be worth making a little note that P stands for primary coil and S stands for secondary coil. And that the reason this relationship exists is because the power on the primary coil equals the power on the secondary coil. So if I was writing that, the power on the primary equals the power on the secondary, and the power on the secondary would be the voltage on the secondary times the current on the secondary, P equals IV. And for the primary, it would be the voltage on the primary times the current on the primary, P equals IV. And if you rearrange the ends of these equations, you should end up with something that looks like that part there. So really this is an origin story, I suppose. I better put this bit in the middle in purple. Power on the primary equals the power on the secondary.